please start the report anytime you like.
Can everyone see Marcus' presentation?
Can the opponent confirm, please?
Yes, I see. Please stop.
Okay, can I start now?
Yes, please.
So, hello everyone, my name is Ivana Hash from Team Croatia, and I'll present you our solution of problem 2 slow match, which says, according which the flame from propagates with a constant low speed has been important to ignite cannons. Produce such cord and investigate their burn rates and other properties. I will begin with the theoretical introduction, followed by the experiment itself, and at the end I'll present the results. Let's see what's burning first. It's a chemical process in which atoms or molecules separate and merge, creating new matter with a big energy release in form of heat and light. Matter that burns is called burning substance, and oxidizer is matter that has to be present for burning to last. For example, oxygen. The whole burning can be simply shown with this general equation in which EA is energy required for burning to start, and ER is energy that is released with burning in form of heat and light. Now we can show the burning of a cord. Let's imagine that we light one side of it. Then the energy releases and spreads to adjacent particles of the cord, and they also ignite. If that chain reaction with an even speed, we call that cord a fuse. In my fuse, the oxidizer source is potassium nitrate and burning substance is sugar. First picture shows burning, or in this case, not burning of sugar. And second picture shows potassium nitrate after exposure to fire. They don't only burn on their own. Burning of sugar makes water and CO2, but what interests us is the large amount of energy released. When potassium nitrate burns, it creates potassium nitrate and oxygen. When these two ingredients burn together, oxygen from potassium nitrate amplifies the burning of sugar, which causes the release of even more energy, enough of it so the adjacent particles also lit up. But it's worth mentioning that if mixture contains a lot more sugar than potassium nitrate, it won't burn because there won't be enough potassium nitrate to produce oxygen. But it won't burn if there's too little sugar in it, considering it is the source of heat. This third picture shows burning of a mixture of potassium nitrate and sugar in mass ratio 3:2, because in the literature I found that's the best ratio of these two ingredients for making a fuse. All fuses made are 30 long. Before the experiment, I've set 4 hypotheses. Firstly, flame will propagate the fastest on the thickest cord. If we change the amount of sugar in the fuse, it will burn slower, if at all, because we will change the ideal ingredient ratio. If we change the amount of potassium nitrate in a fuse, it will burn faster, but only until there is not too much potassium nitrate comparing it to sugar. Fuse of higher starting temperature will burn faster because it will contain more energy at the start. It will require less to ignite. In this experiment, I did 2 tests. In the first one, I used fuses made of core that is 2, 3, and 5 mm thick. Here, I changed the amount of potassium nitrate and sugar in the fuse. In the original recipe, there is 72 grams of potassium nitrate and 48 grams of sugar. But I made fuses with 0, 24, 48, 72, 96, and 120 grams of sugar. In those 6 ratios, I made fuses of all 3 thicknesses. I did the same thing looking for effect of potassium nitrate on burning time. With 48 grams of sugar, I made fuses with 0, 24, 48, 72, 96, and 120 grams of potassium nitrate. In second test, I used only 5 mm thick fuses, made with original recipe, 72 grams of potassium nitrate and 48 grams of sugar, and changed their temperatures by putting them in a furnace or fridge for some time. The temperatures I chose are -15, 15, 30, 50, 65, 75, and 85 Celsius degrees. I measure temperatures with a laser thermometer. I put all fuses parallel to the measuring tape and lit them on an aluminum board. Using stopwatch, I measure time needed for every 10 centimeters of a fuse to burn. I did that because I assumed that cord wasn't equally saturated with sugar and potassium nitrate. I did all measurements in a closed space without a wind, and after every measurement, I removed created smoke with an exhaust fan. I made all fuses as duplicates, so I'll present the results are arithmetic meals of 9 measurements. And these are the results that I got. This graph shows changing of fuses of mass of sugar in it with 72 grams of potassium nitrate. It is visible that the speeds are the highest on the fuse with 48 grams of sugar. Fuses with less sugar had too little sugar to burn, and those with more sugar had too much of it. We can also see that the burning speeds are the highest with the thickest fuses. Some bars are represented with X's, and that means that they were negligible. That happened because the core just burned out because of the amount of heat from sugar, and that heat had no time to transfer. With this graph, we can confirm my hypothesis that changing of amount of sugar will slow the burning down. This graph is burning heat, which mass of potassium nitrate in it with 48 grams of sugar. We can again see that there is no burning in fuses with no or with potassium nitrate. In fuses with too much potassium nitrate, 120 grams, had too much potassium nitrate compared to sugar. The part does not almost immediately burned out and transform on enough heat. With this graph, I will conclude that thicker cord will burn faster, this confirming another hypothesis. Also, we can confirm the hypothesis that more potassium nitrate result in faster burning to a certain extent. Now we're looking at the results of changing temperatures of fuses before burning. Explanation of this is pretty simple. A fuse of higher temperature, that is with more heat, requires less additional energy to light up. That's why flame propagates through it faster. With this graph, we can confirm our final hypothesis. A fuse with higher temperature will burn faster. From this experiment, I concluded that the perfect ratio is really perfect ingredient ratio. In first graph, when changing amount of potassium nitrate, the fastest speed was at 70 of potassium nitrate. In second graph, when changing amount of sugar, the best results were for 48 grams of sugar. With this, we can conclude that this ratio is really perfect match with the literature. And at the end, we can conclude that the fuses made of thickest cores will burn faster, just as changing of the amount of sugar in a fuse causes slower burning because the ingredient mass ratio won't be ideal. Third hypothesis, changing amount of potassium nitrate result in faster burning to a certain extent. It's also true because we again change the optimal ingredient ratio. And the fuses with the highest temperature will burn faster because it will have more energy at the beginning of the burning. This is the literature that I use for this research, and with that, I would like you to thank you for your attention.
Okay, thank you very much for your report, and we now move on to clarifying questions from the opponent, please.
My question is, may you please put emphasis on how you soluted potassium nitrate and sugar in the water and prepared the cords?
Okay, so first I chose the rope. For the rope, I used an organic rope hemp, and then I put the required amount of potassium nitrate and sugar in 150 milliliters of water, and I mixed that for approximately 10 minutes, enough of it so the all water evaporates, and then I put it in the oven for 20 minutes at 150 degrees Celsius so that all the moisture could also evaporate out. Did you hear my answer?
Yes. I've got another answer. 1 second, please. And do you think that there is no spontaneous reaction between potassium nitrate and sugar while you put the coats in the oven?
Sorry, my connection is bad. Can you repeat the question? I didn't hear you.
Do you really think that there is no spontaneous reaction between potassium nitrate and sugar when you put coats in the oven?
No, there won't be, because it already reacted when I cooked it. So when I put the oven, only the water evaporated out.
And why do you think that potassium nitrates do not react with sugar while burning? You think that only potassium nitrate releasing oxygen due to high temperatures?
No, because that energy wasn't enough for a core to burn. Therefore, the oxidizer didn't transform into oxygen. The temperature in the oven wasn't enough for a core to burn.
No, not in the oven while burning.